This video is talking about the second part of Chapter 7, dealing with the normal distribution, starting with Lesson 2, which is finding areas and probabilities. When you use the normal distribution and you're finding probabilities or areas, it's really the same process. You always have to change your random variable x into a z-score, which we learned how to do in Chapter 3. It's called standardizing the normal random variable. You don't really have to know the term for it. To change an x to a z, you have to use the formula where z equals your x value minus the mean divided by the standard deviation. We're going to go through an example to talk about a few of the different characteristics. This example says that IQ scores can be modeled by a normal distribution with a mean of 100 and a standard deviation of 15. It's always helpful to draw a picture of the normal curve. In this case, you would want to put your mean of 100 in the middle, and your other values on the number line would either increase by 15 or decrease by 15 since that's your standard deviation. Those values all represent your IQ scores. The standard normal scores, the z's, are always the same on the number line. The z, if you remember, measures the number of standard deviations away from the mean. So if you're in the center of the distribution at the mean, z will always equal 0, and the standard deviations, each mark on the number line represents one standard deviation, so you just count by 1 in either direction. You use positive numbers on the right side to show that you're higher than the mean, and negative numbers on the left to show that you're below the mean. With the same example, suppose you want to know the percentile for an individual with an IQ score of 120. Remember, percentiles mean the amount of the population that has the same score or lower. So we want to look at how many standard deviations 120 is in comparison to the mean, using that formula for standardizing. So our x value in this case is 120, the mean was given to us as 100, and the standard deviation was given as 15. So I just plug in those numbers, do a little bit of math, finally divide, and for z-scores you always want to use 2 decimal places, so this would round to 1.33. We need to find the area to the left of 1.33. That's actually going to tell us our percentile. So again, I want to draw a picture. I draw a vertical line where I think 120 is, and I want all the area to the left, so I shade to the left. We have a table in the back of the book. This was actually inside the back cover. I had to crop it out so we could look at just the specific area of the table where we'll find our answer. We want to find z equals 1.33. So along the left-hand side, right along here, okay, you have the any value in the ones place and the value in the tenths place for the decimal. So we want to look at 1.3. The second decimal value is listed across the top. These are the hundredths place. So I want the second decimal place to be a 3. So I want to look at that column, and where the 2 overlap is my answer. That can be interpreted as an area, a probability, or a percentile in this case. So that area to the left is 0.9082. We want to interpret that as a percentile. That's about 91% if you move the decimal. So an individual with an IQ score of 120 is in the 91st percentile. Sometimes you want to find the area to the right instead of area to the left. That table that I just showed you is always going to give you area to the left. So you can use the complement rule, or an easier way to find those areas to the right is using the symmetry of the normal distribution. If I want to find the area to the right of z equals negative 0.23, that's my picture. Okay, I drew a vertical line where I think negative 0.23 is. The table that I just was looking at won't tell me the area to the right. It'll tell me the area of the white space. Okay, if I would move this distribution, if I would move the way that I drew it, if I put the line at positive 0.23 and shaded to the left, it would actually be the same amount of area because of the symmetry of the distribution. So if I look up positive 0.23 on that standard normal distribution in the back of your textbook, you could find the area without having to worry about 1 minus anything or accidentally looking up the wrong number. The area to the right of negative 0.23 should be 0.5910. You would want to look for positive 0.23 on your chart to confirm that. If you have an area between two values, you want to start by looking at, I'll just show the full example here to explain. If you want to find the area between z equals negative 0.34 and positive 1.28, what you want to do first is look up the larger z value. Okay, so the area to the left of 1.28, that's going to cover all this purple shading and all this white space to the left. That area is 0.8997. Next, I want to find the area of the white space so that I can subtract it out. So the area to the left of negative 0.34 is 0.3669. If I subtract those two areas, it'll give me the purple space, the area under the curve in the purple space, which is 0.5328. Those are all the types of area problems or probability problems you can encounter that will use the table. We can also use the app StatsMate to find those same areas or probabilities. In StatsMate, you would choose the normal distribution, and you choose the correct area type based on your problem. Whatever value you have for z, for instance, if I go back to the last slide, one of the z values was negative 0.34, I will put that in the A field. And then since it was a between, I would put the 1.28 in the B field and press done. The answer will show up in probability. I took a screenshot of what you would see in the app. When you're talking about the area type, if you touch that blue text on your app, it'll actually give you an option for point, lower tail, upper tail, between. We'll only use lower tail, upper tail, or between for all of the problems that we do. If this was supposed to be a less than or equal to, you would switch it to lower tail. Since I have a z-score, my mean is automatically set at 0 and standard deviation is automatically set at 1, which makes sense for z's. The nice thing about StatsMate is if you have x values, like we did with the IQ problem, you can actually type in your mean of 100 and standard deviation of 15, and then just actually put the x value in your A spot without having to change x to z. It just saves you a little bit of time. You're not always going to be allowed to use StatsMate. Sometimes I want you to show the work of changing x to z, but I'll let you know when you're allowed to do it one way or the other. You can refer back to this slide if you need help remembering what goes in which field. So just some examples that you can check if you're using the app correctly. If you have a random variable that's normally distributed with a mean of 42 and a standard deviation of 6.3, you want to find some probabilities. You'll always round to 4 decimal places with the normal distribution. So I have a few examples with the answers attached. The first one, the probability that z is less than or equal to negative 1.5. The mean of 42 and standard deviation of 6.3 actually don't matter here. Because you're given a z value, you want to keep the mean at 0 and standard deviation at 1. You would type negative 1.5 in your A spot, and it would give you a probability of 0.668. Make sure you change it to lower tail for the less than or equal to. If you have a greater than or equal to, you switch to upper tail, change your A value to 0.52, and it'll give you a probability of 0.3015. And if you have a between, I typed too many decimal places there, but you would put negative 0.01 in your A field, 2.31 in your B field, and when you press done, it should give you this area, or probability. It's in the probability field. You can interpret it as an area or probability. When you're actually applying the normal distribution, if you have a problem like this one that tells you the mean incubation time of fertilized chicken eggs kept at 100.5 degrees Fahrenheit and still air incubator is 21 days, suppose the incubation times are approximately normally distributed with a standard deviation of 1 day. Really what you need to be able to pull from that problem is the mean and the standard deviation. So I want to draw a picture that shows my number line with the mean and standard deviation and my z values going from -3 to +3. I did that. The steps are always going to be the same if you're finding probabilities or areas. You want to standardize your random variable, changing x to z, shade the appropriate area of the picture so that you can see what's going on and if your answer makes sense. Then use the standard normal distribution, that's the table in the back of the book, to find the value of the shaded area. And you'll have to interpret it sometimes depending on the way that the question is asked. So going back to this thing with the chickens, if we want to find the probability that a randomly selected fertilized chicken egg hatches in less than 20 days, I want to start by drawing a picture. I know that x is 20 and less than 20 means I should shade to the left. That also shows me, since it's right on that line, that my z-score is -1. I don't actually have to do a lot of work in this problem. I showed all of the steps in my slide so that you could refer back to it when you don't have an x value that lines up with a z. But the probability that x is less than 20 is the same as the probability that z is less than -1. To find that probability, you want to look for z equals -1.00 on your chart, and you should get an area or probability of 0.1587. I don't know what I just did. There we go. If you want to find the probability that a randomly selected egg hatches between 19 and 20 days, 19 and 21 days, sorry, my picture doesn't match here. The work is correct, but I have to go back and fix the picture. It'll be fixed when I post the notes online. But for each x value, I want to change each x to a z using the formula. So I plug in 19 for x, subtract the mean of 21, divide by the standard deviation of 1. That gives me -2. I take 21 minus 21, divided by 1, that gives me 0. So I go back to the earlier slide. To find that area, I would have to look up 0 on the chart and then look up -2 on the chart and subtract the two areas that I find to get the final probability of 0.4772. If I want to decide if it's unusual for a value, what I would do is I can just look at the z-score. If I want to see if it's unusual for an egg to hatch in less than 18 days, I would change 18 to a z-score using the mean and standard deviation, and I get that z is -3. From chapter 3, we learned that any value that's more than 2.5 standard deviations away from the mean is unusual. This value is more than 2.5 standard deviations away, so it would be unusual for an egg to hatch in less than 18 days. For using StatsMate, it works exactly the same as before. Here are some example problems you could do just to make sure you're using the app properly. If you want to pause and try those, make sure you get the same areas I did when you use the app. If you know the area and you want to find the z-score, you're always going to use StatsMate to do that. What's different is instead of typing in an a value, this time you know the probability, so you'll type the probability in and use the answer that pops up in the a spot as your final answer. Whoops. So there are a couple questions here that I am running out of time on this particular video, so I'll make a second video and I'll start here with example 7, finding z-scores.